Okay, so here's the thing. We have different practices as we are here in this room. Basically, we could most likely learn from each other. I can learn from you, Jill, you can learn from me, and everyone can learn from everyone else. And when you get those all good practices that we use, things that works for us, we can have a lot of things. But if you take any single person, you will find out, most likely not a single one of us actually uses this kind of practices just because, you know, they are not evenly distributed. And so, here will be a talk about things that work for me. Now, the thing is that they work for me, but they don't have to work for you because it all depends on the context. So, for example, I do business applications, microservices, these days microservices, enterprise applications, web applications, all this kind of stuff. But I'm not doing any game dev. And if I were doing game dev, everything I'm going to tell you today can be complete bullshit, right? So take this with a grain of salt and basically be very careful when you apply somebody else's advice. So what's the context? So we can compare whether your context applies, whether my suggestions apply because the context is maybe similar. So basically I've been doing this for the last 20 years, developing applications and designing them as well, because architecture and implementation, so I'm coding architect. 8 years with microservices, the last 8 years, and before that 12 years with monolithic applications, right? And there's pretty much every kind of systems in a lot of domains. After 20 years, you don't care about the domain anymore. Like there have been so many of them that it's not relevant anymore. So imagine this. To talk about good practices, we're going to take an example, and we're going to imagine that we are working in a company, and this is like just a medium-sized event-driven system with Kafka, Kubernetes, 10 development teams, public cloud, all the standard jazz that comes with up-to-date environment, and a very complex domain where we have many devices, IoT perhaps, a lot of different users and different companies that we cooperate with, and we have to invoice them. And we have a system, or a microservice actually, that is responsible for importing invoices. Very simple thing, right? Other companies have those invoices, they send it all to us. The problem is there is a very specific protocol for that, and whoever came up with that protocol was completely dead in the brain because there is no way to actually create a corrective invoice, something which is required by law, but who cares? The protocol does not apply to this. So our architecture in a situation right now looks like this, with this single microservice for a single team. Okay, we have this invoice importer in the middle. There is another billing system, which is something off the shelf, let's say Microsoft Dynamics or something like that, or Subbream, whatever that is. And then there is a bunch of Kafka topics. If you know Kafka, then they will be compacted topics that provide you with data, and some external services, external applications that we have to talk with, and they are not in our hands, they are in the hands of other teams with other developers, and basically other companies. And now comes a new requirement. And that requirement sounds very simple. Because that protocol that we have does not provide any way of actually creating a corrective invoice, what happens is that in those systems is that those corrective invoices, they actually come by email. And there are people who have to enter them by hand, to that billing system, which is just manual work. It's a waste of time. And basically, when you go into a large number of invoices, there'll be also a large number of corrective invoices. So it cannot continue, right? So the idea is the product owner comes in and says, okay, I want to upload the Excel file with those corrective invoices, so I do not need to perform all the checks, validations, and enter the data myself into the billing system, right? That's the user story. Cool. So what's the first thing you should do? Well, a practice that works for me very well is to first never do what they told you to do. So basically don't implement it yet. Instead, ask whether it's worth implementing. Maybe it's not worth implementing, because if I think about it, about 10% of my work time, that means 2 years, I've spent on building software that never got used by any users on production. Okay? And that's because somebody had an idea, and they were very convincing, but basically there were no users for this, or no use cases. It makes no sense, right? So what can we do? First of all, how many invoices do we actually have per month? This way, uploaded this way, so corrective invoices. Because if you have 3, then maybe, working for this for a month by a few developers, it's a huge cost and it makes no sense whatsoever, right? It's cheaper to actually throw some money at a student at Politechnika Warszawska and they'll do it for free, right? Basically. So, and they can do it like for hundreds of years because they are so cheap. So it makes no sense, right? The other thing is, what about the very different data variants? So basically what happens is that we have several 30, 50 different companies that are sending those corrective invoices to us, and there is not a standard format for this. Which means that every time there's a new company, or they have, a new person in that company, they're going to send us these invoices in different format. Which means that if we do not have any kind of a contract for that data, okay, then when we try to read that Excel file, we're going to search through the Excel file basically, and most of the time we're going to fail. That means that the maintenance cost of actually keeping this in production is huge. Every single month we are going to work on this, just because the Excel file changed, right? There's no contract. So that's a huge cost. Then, what is the time and cost for uploading them right now, right? So let's compare the salary of the people that do this job right now to the salary of the developers and do this kind of analysis I just did with a student from Politechnika Warszawska. And so that's what we do. We do not implement it right away, we just try to find out whether it's worth implementing. So let's get some numbers. Right now, processing manually those invoices costs about 40,000 euros per month, right? Sounds like a lot. Well, so if we do implement this, then let's say we're going to lower that number to about 20,000 euros per month, not to zero completely, because, well, again, you have to receive this through email, you have to upload this, basically you have to have a person clicking buttons, because you cannot automate it for a reason, okay? And so let's say we're going to save about half of that, and there's going to be a trust of the billing people increased, meaning that, you're going to have some friends in this company because you did something important for them. And maybe you have some political gains because your product owner is basically playing a political game against other product owners, and who's better at what and what can they get out of it. But what are the cons? First of all, it costs 10,000 euro per month of implementation, right? Just, a single person working for this actually costs a lot, and these are developers, right? The highest cost in the IT. Then the maintenance cost is going to be about, 250 euro per month with the data variation, because you're going to have to go back to it and fix it, right? Or change it. And then there is another thing which is much more important, opportunity cost. Meaning, if I'm doing this, I'm not doing something else. Maybe I can find something much more important for the company to do and to bring much more money than 20,000 euros per month. Right? So this kind of analysis, I guarantee you that it's going to help you. Your product owner might not like it at the very beginning, but when they find out that due to that, they can actually skip and not do unimportant things and instead provide some real benefit for the company, then they're going to get raised, so they're going to love you anyway. So that's one thing. Now let's move forward. So we decide to actually implement this, right? For whatever reason. Then the product owner actually brings us this kind of a mock-up of a UI. And they say, okay, I got a button with upload file, then I need to see some errors when I have them, and I need to see a list of all the old imports, right? And when I see those imports, I would like to download a CSV file so that I can actually fix those things and, basically call another company and find out what's wrong with this file and what's wrong with those numbers, and basically find, have that solved and then upload it again. So that's the idea. That's a mock-up, right? But the mock-up is actually not analysis, meaning that the first thing you should do is not implement anything, but actually create that analysis, meaning, for example, behavioral scenarios. Here you have some behavioral scenarios, and we write them down with no details, just the title. So basically we are saying what we are going to do. Something like we're going to convert each line of the invoice into an invoice in the billing, right? Each line of the Excel file into the invoice in the billing. Or that we should return a list of imports. But then we think about, what are the corner cases can we find out? What if the file is more than 100 megabytes? Do we have enough memory for this? Can we have an out-of-memory error in that case, right? All this kind of corner cases. So you write them down, And then you have to design the architecture. And when I say design the architecture for such a simple thing like importing invoices, corrective invoices by a button, right? People are like, what do you mean by that? We have a microservice, let's put it there. That's it, right? A new feature, a new controller, REST controller, and then just process this and that's pretty much it. Well, not exactly. Because what happens is that, let's take a look at what the cognitive load, meaning the number of things you have to put into your head to be able to work with this microservice, what the number is right now. So right now, to work with this microservice, you have to understand how Kafka works, because it depends on Kafka heavily, right? You have to understand how to read models, how read models work, and how to read them from Kafka with Kafka streams, and how to send events to Kafka as well. Then you have to understand the business process of validating a partner. So basically, another application that you talk with. Then you have to understand the very strange protocol that it has, and what are the invoices presented, so the DTOs, on both sides, right? On the billing system and on the external system. And the peculiar protocol has actually a book about, that you have to read to do it. What happens when we add that feature to that microservice? Then we have additional cognitive load. New things you have to understand when you start working with that microservice. So now you have to understand, and this is in Java, so basically this will be references to the libraries in Java, how to upload a file, basically, in Spring MVC, which is something not very difficult, but normal developers, web developers, don't do that, okay? So then you have to think about, how do I actually read an Excel file? And there is another library for this, and it's huge, and it has a huge documentation for this. And then you want to this list of errors, and you want to return this error as a CSV file, right? So you have to understand how to build that, most likely with some kind of a library. Maybe you'll do it by hand because that's actually simple. And then you have to add a database, because that microservice doesn't have a database. And now we have to store the information about all the failed importing of those Excel files, which means that while it's not very difficult, we have to add the secrets to the database to some kind of a vault. Then we have to add some kind of a migration library, like Flyway or Liquibase in the JVM world. And then we have to add those scripts that actually migrate, and so on, so on. So there's a much more, in terms of cognitive load, the things that you have to understand to be able to work with this microservice. Right? Okay, so what would happen if we were not about to add this feature to an existing microservice inside an existing code, but instead we are going to create 3 modules within that microservice? In that case, take a look at this. Now we have an XLSX uploader, which will be a new module that will take over uploading the file from the web. We will have an existing module, invoice importer, and another one which is called invoice reporter to create those reports that were required from the web, right? When you take this and you think about about cognitive load that now you will have working with each of those modules, then remember, modules, you can work alone within the module. That's the whole concept. Basically, we want to have modules because you can think about within the box and not think about other modules in the application. And when you do this, then the invoice importer module does not change. These are exactly the same cognitive load, the same features that we already had. But if we add another XLSX uploader module, then to work with this module, you have a much smaller subset of actually things you have to understand and put it to your head to be able to work with it. When you go to the reporter module, that's the one that has got DB. So before you actually go there, you don't have to understand how you actually connect to the DB, okay? Or what kind of a migration strategy you have for the scripts and so on. So by just modularizing this simple microservice, okay, and putting it into 3 modules within that microservice, it's much easier to work with each of those modules because there is much less things to put into your head. Okay? And that also means there is a lower implementation risk. Now, if you want to read more about this, the gentleman speaking before me mentioned the book Team Topologies, which actually describes this concept of cognitive load and overload. And that's a very old idea, and it just says if you have to have more things into your head when you're doing something, you're going to do it slower. That's the whole thing, right? If you don't have to think about it, because there's not much, you're going to do it faster. So we're going to speed up just by modularizing our application. But that's not everything. Because one of the jobs of an architect is actually to design for failure. So basically design the system so that when it fails in a graceful manner. You expect the failure. You want to understand and to be able to behave in a way so that it's not the end of the world, basically. So what it means in this perspective is every time you add a new feature, basically, we have to think about, what kind of risks do we have? And most of the time it will be security. So like, the term DevOps, it's actually FinSec DevOps, meaning financial security developers operating their systems on production. So it's much more complex. So in a simplest manner, it means you design something, think about it, how does it impact the security of the system? That's it. What can you do with this? Well, for example, you can do threat modeling. That's a very simple method of actually analyzing, does it improve the security or actually lowers the security, right? Things like analyzing what kind of vectors of attack do you have. So if we do this, for this single requirement, you will find out that because we are working within an existing microservice, right now our surface area for attack is actually going to increase a lot. Because first of all, we are adding HTTP endpoints, UI basically, right? We didn't have that before. Then, so you can attack this way. Then we are adding a large library called Apache POI just to read those Excel files, meaning you can have bugs there. And then you can do errors in parsing, and basically we can attack you by providing strange data within the Excel file, right? And then you have to think about memory leaks. What if those Excel files are pretty large, right? What if this is half a gigabyte of an Excel file, right? So just by adding that simple feature, you're making this a much larger problem, right? Is there another way to do it? How about we were about to create the same architecture, but this time it's not modules anymore. These are microservices, 3 different microservices. Now that's a lot of work, right? Not exactly. Actually creating a new microservice takes 4.5 seconds if you have a good tailored template, and I'm including going to production. So that's what happens when you have a good system, good microservice-based system. But with this kind of approach, there is, of course, a cost of communication with microservices. But now what happens is that we do not increase the attack area, surface area for that microservice which already exists. We add 2 new microservices. Each of them has much smaller attack area, so it's much easier to protect. Okay? So that's what you should do. Think about whether you want to have another module and another microservice in such a case, because there are completely different requirements, non-functional requirements for the process that we are talking here about, which is uploading a corrective invoice, and for the process of just normal working with those invoices for the current existing microservice. So for example, right now, if you think about it, the existing microservice has got an SLA or availability of 99, which isn't high, but again, it's 99, right? We want it to work most of the time. Then the RPSs, are requests per second, are pretty low, and frequency of change is also pretty low. However, if we add these Excel files and processing of those Excel files, for which the SLA or availability is 0, if it doesn't work today, you can upload the file tomorrow, right? There's like, we have 20 days after the end of the month to actually upload those files with corrective invoices. And the request per second is, again, completely 0, right? But the frequency of change, what happens if we don't have a protocol for those files so that every single time we have somebody uploads a file, it turns out that there is a new version, or the data is in a different, basically, order, or maybe in different cells. In that case, the frequency of change is going to be huge. And if you have a high SLA and a huge frequency of change, that's a very bad place to be, because you know who makes bugs? You know what happens? If you want to have a high SLA or availability, you cannot have a lot of bugs, right? Who makes bugs? Developers. When do they make bugs? When they make changes. So you want to have a lot of changes, you're going to have a lot of bugs. Simple. Okay, so then another thing is, this feature actually, because it works like a few times a month, maybe it's not even worth to have it as a microservice. Maybe it could be like a Lambda, or maybe it could be like a cron job of Kubernetes, so that you can scale down to 0 basically, because you don't need to reserve that memory, because it doesn't work most of the time, right? So there are a lot of different options that you can have to think about, and I urge you to think about non-functional requirements for the feature and compare them to other non-functional requirements for the features within the application you already have. Because you can find out that it makes much more sense to actually put it as another application or a microservice in this case. Okay? And then, after all of this, okay, there is another thing, which is, do not try to implement the whole thing. Think about it, about what is the least amount of work I can do to get it to production, to find out whether it works and it's useful. Do I really have users working on this and have the feedback from the users? So even with such a simple story, that was a single user story, right? I'm going to have MVPs. And let's take a look at those MVPs. I can actually basically split it into two different MVPs. One being having all those scenarios that are on the top, and another one, which is the returning list of imports and downloading the CSV file basically later on. You don't have to do everything at once, right? You can have the upper part, deploy it to production, get feedback from customers, for actually the business people who actually work on this, and then decide whether you want to implement the rest or whether you want to move back. It's always, a good idea from a business perspective not to implement the whole thing, but even if it's simple, split it into smaller things that you can get to production, get to user, get the feedback back. So now that we have done all of this, it's time to finally refine those requirements, meaning write the whole analysis. So here we are writing down behavioral scenarios. And this is a testing library for the JVM called Spock, where we put all these things, like the behavioral scenarios, so all the interactions with the system, the user with the system, and the system with other systems, and between different microservices as well, into this kind of stories. When we do this, and when you get it down, so basically we are writing test scenarios, right? When you have it down, then what happens is, first of all, you will find out a lot of interesting things. Like, for example, just to design this, to be able to write those scenarios, you have to understand how the library works. And when you look at how the library works, you will find out that you don't have to load the whole Excel file into the memory. You can actually work on the file on disk, meaning memory leak is not likely, because you don't care whether this file has got 100 megabytes or 500 megabytes, right? And so on and so on. So basically, there's a lot of options there when you can, it's going to be much easier than what I thought, right? For example, or maybe the other way around. And then what happens is, again, we are not implementing anything. We just implemented the test. Not even implemented the test. We would just describe those tests as behavioral scenarios. So basically, given, when, then, all these kind of steps, right? Out of this file, test file, which actually does not run anything yet, what I get is this. This is a reports from Spock reports, meaning this is a readable web page for the business people to verify how we think it should work in different cases, especially corner cases, is exactly how it should work. So now I send this file to the business people to verify. So I'm not implementing something and learning later on that they said, no, it cannot work this way, right? Simple. And so let's take a look. We haven't wrote a single line of a production code yet, but we have verified the validity, whether it makes sense to implement this. We have designed the architecture, designed for failure, analyzed done a little bit of a threat modeling there. We split this solution into different MVPs so that we can do something smaller and get feedback faster, refine the requirements as behavioral scenarios, and basically send them to the business people to verify the requirements, whether we understand them correctly. And the best part is, this is done in 1 hour. All of it. It might sound like a lot of things to do when you do it the first time, but when you are used to it, it takes 1 hour and you're done, right? And we have a lot of positive feedback from this. For example, I don't have to implement every single stupid idea that my product owner has, which is great, okay? So now it's time to actually implement the code and basically write this thing, right? And here is a problem, because sometimes when you actually have this kind of a feature to write, it's very simple. Sometimes you just see the solution yourself, right? For example, I've spent a few years on content management systems, on e-commerces and stuff like this. So I can see the code within my mind eyes when somebody tells me about the features for e-commerce or a content management system. It's that simple after a few years, right? But what happens so you can print this code, wake me up at the 3 a.m., ask me for a feature, and I'll print the code out like a printer, right? But what happens when the feature is not that simple? And here are two things that happen at this point, or might happen, okay? Sometimes the senior people are getting stuck with thinking the same way that they always did. So basically, I have one tool or a few tools, right? This is a new problem. I'm going to apply one of those tools whether it works or not. And they try to implement that feature, and it's an ugly implementation. It's a very naive implementation of the feature, just because we are trying to use the same practices we did before. Now, for junior people, there's another threat, which is, I ask them, so somebody says on the planning session, for example, or on the daily, I'm going to take this, and this is a junior developer, right? And I'm asking, and then next day they basically on the daily and say, yeah, I'm still working on this. And the next day they say, I'm still working on this. And so I ask them, do you need any help? Do you have any blockers? No, I'm still thinking about how to do it, right? And after a week, they say, I don't know how to do it. So you've wasted a week of time, basically, on doing what? Waiting for the idea to come up, how to solve this, right? No, it makes no sense. So basically what I would like to show you is how to solve this kind of a problem when you don't know how to do that thing, how to solve the problem, right? And there are many solutions to this. First one is called baby steps test-driven development, right? Which is, take this problem, get a subset of this problem so simple that it's naive, and then try to implement this and implement a test on this, and then move forward one step forward, right? Again, a very simple thing. So how would that work? It would be something like this. Here is the scenario that we want to implement. Should convert each line except header into invoice event. And that's a huge one. That requires the whole thing to work, right? But we can split it into smaller ones. For example, here you will have the first thing I want to do is I should pass upload result to the reporter from the first module or the microservice to the second one, right? That's it. And if you think about it, the implementation is trivial because you don't have to parse anything. You just pass, whenever somebody calls you, you just pass something to another module or to another microservice. That's it, right? Okay, so what's the benefit of this? Well, we are moving forward. So let's do another thing. Okay, so now I would like to, when the file is uploaded, I would like to see the result. I would like the result to have a name for it, right? So baby step. Now I need to at least be able to read the file. So I'm learning how to read the name of the file. I'm not parsing the Excel file yet, right? Only the name of the file. And then you take another one. How about we see the result that contains the username? Oh, and now I have to learn how to get the username from this whole system, basically, right? And one by one, you move forward. And the thing is, it doesn't sound like a complete, implementation, because sooner or later you will have something like, I need to know how many Excel files, how many invoices are in the Excel file, and you will have to read this file, right? But you are much closer than you were before to the proper solution, and basically now you have to only understand how to count the number of rows in an Excel file, not read them actually, right? So you're moving by very small steps. And this is going to unblock you from spending 5 days on, I don't know, right? I'm experimenting, I'm learning things. I have a bunch of code that does something right now. So maybe it's easier actually to implement now error cases. Instead of reading all this, implementing the, reading the whole Excel file, then you can say what should happen when the file is not there, and so on and so on. So very small baby steps, not to get you to the goal, but to unblock you and keep you moving, basically. But sooner or later, you will have to read that file. And basically, that's the end of the happy path. Now we have to actually learn the library and how to use it. But with those baby steps, you will have a bunch of code. You will have a much faster feedback. That's not the only option you have. How about doing something completely different, which is called backward programming? And what that is when you have to implement a method. Let's say we have this large scenario with, reading the whole file, understanding everything, importing invoices, all this kind of stuff, right? What we could start with is go into our method and start from the end of that method, meaning what do I have to return, right? Now think about the next line. How do I get that data? Where do I get that data from? So for example, I need to return a result, right? Well, how would I get that data? Well, if anything is basically, if we have anything to report as a successful import, then we would return a result. And I can implement that method saying, oh, I would like to have this result. I would like to have a method called successfully imported in there that will tell me exactly if I have more than 0, right? Then you will say, okay, how do I create that result? Maybe I will have a method which will provide me with successfully imported the number of those rows, or maybe all the rows, maybe failed rows, and maybe the username, and so on. So you're moving from the bottom up. You're not writing from the top down like usually, but from the bottom up, looking at what you need and where can you get that data from. And if you do this, you will find out that quite often it's much easier to do. Because I don't know how the whole method should look like, but I know what I need to return. And let's think about where do I get that from, right? So that's the backward programming, from the from the bottom to the top, basically, right? Now, this will also keep you moving, learning about what you actually have to do, right? And not get you stuck. But that's not the only option you have. You can do this kind of a high-level design. Maybe you remember from the university or the Politechnika Warszawska, for example, when you were designing, maybe you didn't, I don't know if it's still relevant, but basically back in my days, they would teach you how to write an algorithm without any actual language. So it's like a high-level abstract design of the thing that you're going to do, right? And you can do the same thing with a real language. So for example, I can think about, I think I should open the workbook, which is the expressing the Excel file, then load a sheet because they got sheets, right? Then convert all the rows, then have some kind of a result object for all those rows, export them to another system, and basically you're writing the whole method on the top level with no concern for the actual implementation at the bottom. So you're not trying to go like from the top deep down, but just like a spread search for possible solution, right? When you do this, it's going to create a lot of problems because you are ignoring all the dirty details. This method, this library throws exceptions that you have to take care of. There are many things that can happen. There's actually all those small details which make our work very fun, right? If it wasn't there, the business people would be able to write this code themselves. But that will also get you moving and thinking in terms of a solution instead of a blank paper. Right? And there's another method, which is learning by chaos. So for example, here we can just try to read the file and of course print dupa somewhere there, right? Try to read some lines and print the dupa there as well because, tradition requires that we print that, right? And basically play around and fuck around the file and the whole importing mechanism, right? Just to see how it works, right? But it makes no sense. This is not, this is not craftsmanship. This is bad, ugly code. How can you do something like this and show it to us? Well, there's one trick, The trick is never push this to repository. Okay? Just play around, fuck around. Nobody will know. It's okay. It's completely fine. Experienced senior developers do it all the time, right? You just never see the effects of that work because, they don't push it into repository. But if you pair program with them, you will see they do that, okay? So there's a lot of way to do it. So which one is better when you are blocked, basically, right? And which method is the best here? And the interesting thing is neither, because it's not about getting an outcome. Neither of those methods will provide you with a good production-ready code that you will have on production. You will be able to deploy on production, I hope, unless you work in those. But what that means is that they will unblock you and you will learn from this so that after 5 days you don't have nothing. Instead, you have something, you have learned a lot of things, and you can move forward. And here's the most important part. Most of the developers think that they are a fucking plotter machine. Meaning, all the lines I'm going to put on this paper are perfect. And I need to understand, to know what the lines are in advance, basically. But that's not how creative process works. Okay? You're not just creating the final solution right away. Instead, what happens is that when you are in a creative process, I have a sister who is a graphic designer, basically. They do a lot of, they try a lot. So this is like an incremental process here, right? Getting closer to the solution. And we kind of understand this because we understand we can do refactoring later on, right? The part that we do not understand is that that's not actually how it works. Okay? It's not like you will move forward all the time. Instead, what happens is that the creative process goes in a different way. What really happens, because that's your solution if you try to push this, right? Is that while the refactoring of code is very important, you have to do it, that's the only way to get perfection. Before you actually create this code, you have to play around, and those graphic designers, they do a shitload of drafts. Basically, if they want to create a picture, draw a picture, right? They will do about 50 different drafts, just taking a look and thinking about what is the pose of that lady to express what I want to express. And they will throw them away all the time. And they can do it for hours and throw them away. And then when they learn and they understand what I want to achieve and how it works, then they're going to sit down and actually try this iterative process of improving the thing that they draw. And we should do exactly the same thing. But again, a lot of product owners will just hit you in the head and basically tell you, work faster, my slave. You have to do it perfectly, you have no time to fuck around. My answer is, don't tell them that you fuck around. Just fuck around. Learn about what you do, okay? Learn about the different options that you have to express this code, basically, so that it's readable, so we can work tomorrow on this, right? And it's not just another, the same solution that you did for the last 5 or 10 years just because you've never learned anything else. No, you learn by trying things, not by sitting and expecting, the idea to come up to your head and just throw it away all the time. Okay? And you may think that's not exactly how the professional developers work. For example, there is this guy in the Java world, there's this guy called Josh Long, who did about a few thousand, he's a developer advocate, meaning he's done a lot of, I have no idea how many, but a few thousand at least presentations of live coding, okay, on the stage. And when people see how he does live coding, they are like, whoa, I want to be like this someday, right? Because he's so fast and he's coding all the time, talking and coding all the time. And you basically see him, he writes faster than you think about the solution, right? But here's the thing. He did that a few hundred times before, and he's just repeating himself. And the first time he had to come up with this kind of a presentation, it took him a week to work on. How do I know about that? Because I do exactly the same thing. It takes a lot of time to train, to remember all of this so you can talk about it and at the same time do it, right? And you have to understand what's the outcome that you want to get. That's the only way when you want to actually do this kind of a live coding exercise and so that it looks really cool, right? And people don't know that that's exactly what happens. This is the guy. There's a lot of TV shows on how to paint, and this is one of the best of them. This gentleman actually would paint a picture, talking as he goes on TV, basically live, and talking all the time about happy accidents. That if you make a mistake, it's a happy accident because you can use that mistake to create something new, to open up your mind and basically draw something, right? And it looks beautiful. I love watching this guy basically because of all the positive emotions he has when he's drawing all those, painting all those pictures. Now, here's the funny thing. When he does this, he makes you think that he doesn't know where he's going, that all those mistakes are real. The funny thing is, before every TV session, he actually painted that picture once at least. So after he was dead, they were selling all the old pictures for every single season, every single TV show that he did. And now you learn that actually all these happy accidents, they were planned. He did that before, and he spent a week on this, right? Before he was actually showing this. So basically, he was fucking around for a week just to give you a single show, right? That's the senior developer there. And that's exactly what you should do. Okay, that's 6 p.m. How much time do we have? Over.
Maybe a few minutes.
Maybe a few minutes. Okay, so that was my advice in terms of what you should do because, well, as Hemingway said once, the first draft of anything is shit. Okay? And when he was actually writing the, what was it? He was writing Farewell to Arms. He wrote the beginning of it 50 times and threw that away, right? So do this and don't tell anybody, because if you're going to talk with your product owner and tell him that, you know, you're just throwing away all those branches, they are not going to like it. But if you just delete those branches, if you even have to push this to repository, then it's okay, nobody will know. And the end outcome will be you're going to get there faster than instead of, you know, thinking about I need to have the perfect picture in my head before I actually write the code. Or trying to use the same pattern that you did the last time with another feature, okay? So fuck around, implement it, delete it, implement it again, get closer, repeat, don't be afraid of wasting time. You're not wasting time, you're learning. You are learning about the area of different options that you have, different solutions that you might have, to choose the best solution that you will get, right? You're not a printer, you're not a plotter. You learn by making mistakes, not by listening to some guy on the stage, right? You have to actually make those mistakes. That's how your brain changes, okay? And rewriting this implementation, you may think that, oh, but this is going to take so much time because I'm going to rewrite it all over and over again. When I make a mistake, I'm going to delete it, try again, right? No, that's not the case. Because if you think about it, most of the time developers do not write code. They try to think and find where to write, what to write, and how the hell is it going to behave, right? Just the fact of writing the code faster makes no sense to us because we don't spend most of the time actually putting the, pressing the keys on this keyboard. At least not to write the code, actually to understand how to do it correctly, right? So it's completely fine. Yeah. And also that if you delete this code often enough, what will happen is you will learn how to be egoless, meaning you will not be the victim of your own code that you cannot delete anymore. I saw a company once where what they did, they had a Git repository, like everyone these days, and they had like hundreds and thousands of methods that are not used on production anymore. And I asked them why. Why do you have V5 of the API, and V4 and V3 and V2 and V1, when your mobile app actually moved to the V5 half a year ago? Why do you keep all of them there, right? And they couldn't answer. The answer is they couldn't push themselves to delete this. And they have a repository which remembers everything, right? But they just like, I wrote this is mine. I have to keep it on production, right? It's not been used. It doesn't matter, right? It's my life. No, learn to delete the code. The code is shit anyway. You're going to learn how to do it better. Delete the code, write it again. Don't worry about this, okay? So, how much time do we have?
Please finish.
Okay, finish. Oh, there are just 30 more slides. So here's the thing. Now that we wrote the code, it's ready to go into production, right? Well, not yet, because you see, this is the picture. I know it's a kind of blurry, but this is the whole universe, the whole visible universe. This is all of it, because the universe expands. So due to the speed of light and that it expands, we're going to see less and less of it. So the next generations will not be able to see as much as we do, okay? So this is the whole visible universe. Okay? And your application, at this point, is not in the fucking visible universe. That's the problem. What do I mean by that? Well, we don't know what the app is doing when it goes into production at this point, because we have the code, but most of the developers, what they do, they don't provide proper logging. For example, here's the thing. Take a look at this method, which I showed you before. It looks quite okay. We want to send result to reporter when we have something to report to, right? If we didn't import anything, why should we send a result to another module or microservice? What would be the point? Here's the thing. Think about what happens if it goes on production and somebody uploads a file and nothing happens, right? And they say, oh, I can't see the reports for this, right? Now they will call you, and basically you are now a customer care for your business, right? And you will say, oh, give me the name of the file. And they'll give you the name of the file, and you're going to search through logs to see what happened. And you're going to see nothing. Because this code has a branch in it. We can do something or do nothing, but you will never know that you did nothing for a reason. You don't know if the app actually crashed, or maybe some other thing has happened, you know, cosmic rays, whatever. Yeah? So that's the typical problem. Well, not too many developers actually understand how to do logging properly. And the answer to this is very simple. What you have to do is you have to put logs on every single branch, logical branch of your code. That doesn't mean put the log on every second line. I've seen solutions like this, and they are ugly, and you cannot work with the code anymore because it's log dupa everywhere, right? But instead, what you have to do is whenever you have a logical branch, the code can go this direction or that direction, and doing nothing is one of those directions. Then you have to at least log when you don't do it, right? So that we can actually, here we expect what will happen in production from time to time, what kind of questions we're going to get, and how am I going to answer those questions when I get them from the customer, right? So do this, but not only that. The thing is to provide the whole observability, meaning to be able to see what's going on in the production without a debugger. And that requires both logging on every single logical branch and not logging when there is no branch. If you're just following, you know, step by step, the process is linear, right? It makes no sense to put a log there because you know what exactly will happen next. You can look at the code. But if it branches, you have to put the log there. But then you have to think about business metrics, okay? What should we show so that we understand how the application behaves in production? Like, for example, I'll give you a few examples. Number of uploads, right? How about distribution of the sizes of these files? We will learn a lot if we understand, are those big files, are those small files? What can we optimize from this? We can put a metric on the number of failures per invoice, right? Does it increase? Are those invoices better or worse? Okay, and so number of failures per failure type. What kind of errors are the most common? All these kind of things, right? And you can put them as you write this code with libraries that actually provide you metrics. And this will make the application observable. And what happens next is beautiful. Because instead of wasting your time searching through logs and finding nothing, and then trying to basically become a Sherlock Holmes and find out what the hell happened on my application. Every time something wrong happens and somebody calls you, you will have it right in your face. And the best way to achieve this, from my perspective, is something like, let me show you this. I do test-driven development, actually behavior-driven development, so I write tests first, all the time, right? And when I write those tests, if the test fails, I'm writing the test, then I'm writing the implementation, changing the test and the implementation as we go. When I have a problem, and every developer does the same, I will put a breakpoint there, right? To find out what's going on with that variable, or what happens when I call this method, right? Well, stop. Because on production, you don't have that debugger yet. And sometimes you can't even put it there because it slows you down, the production down. So instead, what should happen is take a look at your logs and see if you can understand when the test is read, basically. You're writing a new test and the test is read, fails, but it shouldn't fail. I actually have an implementation for it. Now take a look at the logs. Do they tell you exactly what happened? If they don't, they will not tell you what happened when you go to production. If they do, you don't need the debugger anymore, okay? So it's that simple. But to get there and to have this kind of, this is an example of those logs from real production, to have these business logs which actually tell the whole story and explain what's going on with the system step by step on every single branch, you actually have to remove a lot of clutter because those logs actually look like this at the very beginning. all the libraries are trying to log something, right? And you cannot find shit in those logs because there's so much stuff there that your logs are basically at the very bottom or somewhere in the between. Like, and that's why a lot of Polish developers write this log dupa, because then we can search for dupa and we know this is our error, right? Or our log. That's why we do it. But basically, the proper way to do it is to remove all this clutter by configuring the logging framework. And it's very simple. You have to have some files. I have a solution for this for Java. But basically, every single library will allow you to configure, turn off all those not interesting logs from all those libraries. Leave the ones that are interesting. Okay, or put them at the error level when they are interesting, or the warn level, and remove those infos. And put those logs that you are interested in, especially your own logs, there, so they tell you exactly the story. And you will have something like this, which is actually from the unit test that I was writing, and basically giving me all the feedback. I don't have to look at the debugger, because you most likely do not have a debugger on production. Although it's possible, but not too many companies do it, right? And it's after the fact. Okay. One last thing I can recommend is doing mob code review. In a lot of different companies, code review is something you have to wait for, you have to ask for. Basically, you have to beg for it, and the next day maybe it will happen or not. A simple solution to all of this, if you have such a situation, because not every company has it, if you have a daily, like a daily stand-up meeting, you know, Scrum, then after the daily, at the end of the daily, you can actually say, okay, let's do the reviews for all the pull requests that we have, where actually the author of that pull request explains how it works and what's going on with this pull request. And everybody is giving them feedback right away. What happens is that the feedback will be much faster, because now you talk, you don't have to write it, right? Much easier to understand large pull requests. Maybe you shouldn't have large pull requests, but when you have, because some things are big, then it's much easier to understand when the author of that code actually explains this. And also, it's quite fun when everybody does this. Even my cats actually are sitting here and watching the pull requests, you know. The pull request is actually on another TV. They are not too smart yet, but I'm teaching them programming. Anyway, so you can do it, and you can have those pull requests verified in a funny way, where one of the benefits of this kind of a mob code review is that we share the way of thinking. So basically, you will learn a lot about how other people think about the code. And if you have something to share with them, they will learn from that as well. So we are bringing all of us up in terms of the skill set. Because now we can talk about this, and everybody sees the pull request and talks about it, right? Okay, so now I don't have time to talk about the bugs on production, which is a shame, but you can read it later on. This is the list of all the practices that I've mentioned, and one of those that I didn't have time to mention. And you can find my slides on this link. So if you need to make a photo, that's the only slide you need. And I suppose this will be also available somewhere in the on the site or somewhere else. Thank you very much.
Well, congratulations. It was great. Any questions? Yes. Okay. Thank you. Please.
Thank you. So I have one question about what you were saying about junior developer that was, thinking for a few days and without any result in written code. And then a few slides later, you said about senior developer who is doing exactly the same. I mean, that it is a good practice that we are thinking for a long time, not writing code and doing it, writing code, deleting it, and writing again. So I have a question: why it's when junior does it, it's bad, and when a senior does it, it's a good practice? What's the difference?
Sure. Thank you. We only have one mic.
At the moment, but I'll grab the time.
So when I was talking about this, that was the case when the senior developers are on a shorter fuse. Basically what they say is that, oh, I'm a senior developer, I'm supposed to write the code, so I'm going to write the code, no matter whether it's good code or bad code, I'm going to use the same patterns that I know. Now, this is what happens when you don't know and you're afraid, okay? But the difference is, with what I showed, is we are playing with the code. We are writing the code all the time. We're just not pushing to the repository. There is a difference there, because that guy wasn't actually pushing any code to the repository. He was reading the code and thinking for 5 days. That's it. And he's a friend of mine, and he's a very good developer from my perspective, concerning his age, right? But the problem is that he got stuck because he wanted to find out the optimal solution on the first try. And he was afraid to just play with it. And the difference is that the senior developer will say, I cannot find the perfect solution by thinking about it. That's not how it works. The way it works, I'm going to play with it. I'm going to do some programming. And my brain is going to basically switch. Because if you think about it, if you read any books on neurology, what you will find is that we change our brains during the sleep after making failures in our life during the daytime. So basically you have to fail and you have to feel the pressure from that failure, not too large, because if it's too large, you know, you're gonna get depression. But basically you have to feel, I failed, I fucked up, right? And you go to bed. And this is where you try to do something, learn a skill by doing, not thinking about it, but by doing, okay? And you make failures. That's when your brain actually changes your neural network and creates new paths, basically, or reduces existing things to provide you with, to do it easier and better. So we do not learn by reading books, unfortunately. We learn by getting the knowledge in and trying it out. Sometimes it's enough to, you know, there are things when all you have to do is think about the book that you've read, and then you will learn something. But in our case, in programming, most of the time it's about doing it, you know, for yourself. Right? So all I'm saying here, don't try to, you know, wait till the idea comes up and find the perfect solution. Play around with it. Try different methods that you can use just to, you know, to unblock yourself. Okay? I have a list of those methods here, and this is not a finite list anyway. So basically, try to do something and learn from doing. Just don't push it to production, because then they're gonna kill you.
Thank you very much. It was a great talk. Bravo.
Thank you.